Gaudensor State University main campus. And now, we are going to tackle about X-ray. First, what is X-ray? An X-ray is a common imaging test that has been used for decades to help doctors view the inside of the body without having to make an incision. In the 100 years or so that followed, this basic X-ray technology has become a key element in the identification or diagnosis and treatment of many types of medical conditions.
Some conditions that may call for an X-ray include digestive problem. Digestive problem is the infection of the digestion. Digestive problem is the infection of the digestive system having a problem in the digestion of food. Enlarged heart, the type of problem of the heart having an abnormal size of the heart. Breast tumor, an abnormal benign or malignant new growth of tissue on the breast of a certain person. Arthritis, a disease that causes the joints of the body to become swollen and more painful. Infections, a type of disease caused by germs that enter the body.
History of X-rays. The search for materials that emit radiation began soon after Wilhelm Conrad Röntgen, a well-respected physics professor at Würzburg, Germany. X-rays were discovered in 1895. He was working with a cathode ray tube in his laboratory. He observed a fluorescent glow of crystals on a table near his tube. The tube that Röntgen was working with consisted of a glass envelope with positive and negative electrons. Röntgen was unable to explain the nature and origin of this unknown and invisible radiation, hence he called it X-ray. In 1912, X-rays were used little outside the realms of medicine and dentistry. Through some X-ray pictures of metals were produced. The reason that X-rays were not used in industrial application before this date was because the X-ray tubes broke down under the voltage required to produce rays of satisfactory penetrating power for industrial purposes. That changed in 1913 when the high vacuum X-ray tubes designed by College became available.
Okay.
Wilhelm Conrad Röntgen in 1845 to 1923, courtesy of AIT Emilius Seger Virtual Archives, Röntgen discovered that X-ray can be generated by directing a cathode ray against the wall of glass tube. He was also able to identify some of the properties of X-rays. He found out that like light, X-rays expose photographic film. People were fascinated by the fact that X-ray could pass through paper, human flesh, and even thin sheets of metal, and the pictures of the same material could be seen in the film.
And now, let's talk about the structure and function of an X-ray machine.
The X-ray machine is an electrode peer. So when I say electrode peer, it is an out or battery device that consists with a cathode and anode. Cathode is a part of an electrical device such as battery with a negative charge that where an electron's beams enter. Anode is a part also an electrical device such as a battery with a positive charge that where electrons beams leave. Lead case, an insulated electrical conductor connected to an electrical device. Motor, machine that has produces motion or power for doing work, and a small compact engine. Filter. Absorb light of a certain wavelength or color selectively, and it is used for modifying light that reacts sensitized photographic materials. This part sits inside a glass vacuum tube. The cathode is a filament, like you might find in a common fluorescent lamp.
Radiation protection. Radiation protection, sometimes known as radiological protection, is defined by the International Atomic Energy Agency as the protection of people from harmful effects of exposure to ionizing radiation, and the means for achieving this. The IAEA also states the accepted understanding of the term radiation protection is restricted to protection of people. If we talk about radiation protection, it tells on how we can protect people from harmful effects of exposure to ionizing radiation. And what is ionizing radiation? Ionizing radiation is a radiation that carries enough energy to free electrons from atoms or molecules, thereby ionizing them. It is made up of energetic subatomic particles, ions, of atoms moving at high speeds and electromagnetic waves on the high energy end of electromagnetic spectrum. Examples: gamma rays, X-rays, and UV light. It can cause damage to living tissue known as deterministic effects and stochastic effects.
Radiation exposure can be managed by a combination of these factors: the time, distance, shielding, and alarm. Basic principles of radiation protection. Radiation protections are at time, alara, shielding, and distance. Time and distance. Time. The less time that people are exposed to a radiation source, the less the absorbed dose. Distance. The farther away that people are exposed to a radiation source, the less the absorbed dose. Shielding. Barriers of lead, concrete, of water can stop radiation or reduce radiation intensity. Alara. Radiation doses should all be kept as low as reasonably achievable. This means that it is not enough to remain under the radiation dose limits.
To reduce doses from intake of radioactive substances, the basic countermeasures can be considered. First, shortening time of exposure to contaminants. Second, preventing surface contaminations. Third, preventing inhalation of radioactive materials in air. And lastly, preventing ingestion of contaminated foodstuffs and drinking water.
Thank you for watching.